Hi again. In this video, we're going to talk about graphs and statistics for a single categorical variable. So we're going to switch over to categorical variables, and we have an example here. So for a single categorical variable, we usually make a frequency table. And then in that table, here's an example right here. We have the category names in the rows. So this is an example of a student survey that was given to a group of students on their eye color. And so then the results were tabulated up. 5 students had blue eyes, 13 had brown eyes, 2 had green eyes, and 3 had something else, a different color of eyes or something else. Okay, so this gives us the category names in the rows, and then records the total in each value. Okay, so this is the count, and then we're also going to find the relative frequency, which is the percentage. Okay, now there are 2 types of graphs we can make to show, well, there are some more. There's 2 basic ones, bar charts and pie charts. Those are the ones that we're going to make. And there are some a little bit fancier ones that you might learn about later in another class. Let's go ahead and total up. We need to understand first how many students were in this class, how many took the survey. So let me add these up. We have 5 plus 13 plus 2 plus 3. So we have a total of 23 students. And we could have done this with our histogram as well, but it would have been a bin, like, for example, 30 to 40, 40 to 50, you know, but 30 to 39, 40 to 49, 50 to 59. But we did it on a histogram instead. We just graphed that count on a histogram. So it's a little bit similar. Now, I want to get the relative frequency or percentage. So to do that, we're going to divide. So we're going to take 5 out of 23 students and see what percentage that is. So 5 divided by 23 is 0.2173 with a 9. So that's going to be a 4. So I'm going to write 21.74%. I'm going to keep 4 digits on these. Okay, let's do the same thing for brown eyes is 13 out of 23. 56.52%, and that's a 1, so I'm going to keep it. 56.52%. Next color, I believe, is green. Yes. Green is 2 out of 23. This is 0.08695. So 8 points, and the 69 goes up to 70. So 8.7 or 8.70%. Either one of those is fine. 3 out of 23 is 13.04%. Okay, great. And if you haven't yet watched the rounding video and the percent to decimal video, watch those because that gives you more information. It goes slower on those. Okay, now these should add up to 100%, right? Depending on rounding, it could be slightly off, but should add up to, or should be close. Okay, so we now we know what a count is, frequency or count, and then a relative frequency. And we saw relative frequency on the histogram as well when we changed the scale to a percentage. Okay, so we're to make our graphs, bar chart and pie charts, we're not going to do them by hand. We're going to use technology. And we're going to go to Staplets, which is an excellent tool for this, just like we did for the numerical variable. So let me switch over to Staplet.com. And this is if you go to stapler.com, but I'm usually give you the more specific link in our course. But if you're at stapler.com, it's the very first one. One categorical variable, single group. Okay, and as always, we need to type in our variable name so it will label it for us. So I'm going to write student eye colors, or student eye color. It gives me two options to input data, either the counts in categories or the raw data. This is great because some programs you have to do the counts first, but raw data would be if you had a list of blue, green, brown, 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 blue, green, other. That would be the raw data, and you would put that in just a list. But we don't have that list with us. We have the actual categories. So then if you select the categories, counts in categories, you can type the names so that it will label those. So blue has a frequency of 5. Brown has a frequency of 13. And then I'm going to click on the plus symbol to add another row as I need to. Green, and you can use the tab to go over 2. Another row with the plus sign, other. Tab 3. Now you don't need to do the totals. The computer will do that for us, so that's really nice. Then I'm going to click on Begin Analysis. Okay, I need to move it down here. And it says Plot Type. It came up automatically with bar chart. And it says Label bar chart with frequency, so you can see the counts, 1, 2, 3, 4, 5. Blue, 13 brown right there. So that's excellent. And you can also, you have the option of changing it to relative frequency if you want that instead. And that's the percentage. So that's 5%, 10%, 15%, 20%. Notice down below, it also calculates the relative frequencies as well. So I wanted to do it, to show you how, but now that you know how, you're welcome to use the computer to do it. So I'm just going to double check that we got the same thing. Yep, and it says it adds up to 1. This is in proportion. They didn't change it to percentages. They left it in proportion. Okay, so there's our bar chart, and I have copied this into our next notes page. So I'll show you that. And then you could do a segmented bar chart, but it tends to be hard to read. And then you could do a pie chart. So that's our other type. Okay, so if you are getting these into your lab or homework or quiz or anything like that midterm, then you want to use a snipping tool. I have mine open already. Just look on your computer or Google for a snipping tool. For me, I hit New, and then I can use my crosshairs to, I might want the pie chart or I might not want it. Then that produces an image and it puts it in the clipboard, and then I can paste it into my document or wherever I need it. Okay. Great. Okay, so let's go back to the notes and I will show you. This is just a blank at the bottom of this page is just some directions for you. Enter the variable names. So you have directions down here. And then on the next page of the notes, I have the screenshots, just like I just did. And I wanted to write on here, notice the difference between a bar chart and a histogram. So the bar chart does have spaces in between. So I'm gonna make a note of that. That is a difference, spaces between, sorry, just want to be more specific. Spaces between the bars. So in a histogram, we generally don't put spaces. Some programs do put small spaces, but the difference is so that your eye just tells you that whether it's categorical or numerical. So when I just glance at this, I see these different categories. There's no order to eye colors, right? So I could have put brown first and then green and then blue and then other. So these aren't ordered, first of all, and they're categories versus a numerical variable with a histogram. They're numbers and they are ordered, so that order does matter. Okay, so I'm going to also write a histogram should not have spaces. Between the bars. Now, if there's a gap, if the bar is missing, that means there's a gap in the data. That is fine. But that's what that shows us, is that there are no numbers in that bin. Okay, great. So these are the types of graphs we'll be using for categorical, a bar chart or a pie chart. Now let's get to some statistics, which we already calculated are relative frequencies. So we'll probably be using some of those again, but I want to show you how to write some sample proportions. So depending on the question, this says, what proportion of the group has blue eyes? Okay, so that is one we calculated, and we could write, there's a couple ways to write it. P hat is the notation for a sample proportion. So I could write P hat equals 0.2174. And of course, we got that from 5 out of 23. So I'll just put that there for reference. We can also think of these as probabilities. If a student was chosen randomly from this group, what's the chance they had blue eyes? And in that case, I might write it more like, what's the probability that someone had blue eyes? Probability of blue. Same thing, 0.2174. Okay, so you might see either of these in textbooks and homework systems. I'm going to tend to use the second one because it just gives us more information. The p hat doesn't tell us what probability we're finding. So I'm going to switch to the second one. What proportion of the group has brown eyes? So I'm going to write probability of brown. Brown. And remember, we got that from 13 out of 23. So if we hadn't already done it, I would go ahead and divide it. And we got, it's really small for me to read, 0.5652. Now, they're asking for proportion, so that's a decimal. Okay, but if it asks for a percentage, I could switch it like we did earlier, 56.52%. So that's if it's asking for a percentage. In the My Open Math homework, just look really carefully as to which one it's looking for. If it has a percent symbol after the box, it's looking for a percentage. And if it doesn't, it's usually looking for a proportion. And the wording should also tell you which one it's looking for. Okay. What proportion of the group doesn't have brown eyes? Okay, so now we need to do a different type of calculation. So I'm going to write probability of not brown. It's like everything else except brown eyes. Okay, so now I'm going to count everybody else. There's two ways to do it. You might have thinking of a different way. I can count 5 plus 2 plus 3 out of 23. So let me calculate that. 5 plus 2 plus 3 is 10 out of 23. Divide 10 by 23, I get 0.434, and I'm going to round that to 8. 0.4348. Okay, did you think of a different way to do it? There's also a subtraction way, right? Because probabilities, proportions have to add up to 100%. Our total is 100%. So we could have used a subtraction way of doing it and said 1 minus, well, we already know brown is 13, so we could have gone 1 minus 13 out of 23, and we already know that's 0.5652, so we could also do 1 minus that. Okay. I'm just going to assume we haven't done a calculation before, so I'm going to do 1 minus 13 divided by 23. I don't want to hit enter first because I want this to divide first. And you can see we get the same thing, 0.4348. Okay, I'm going to make my 1 a little bigger so it matches the height of that fraction. Okay, so do different things to go there. Sometimes this is called a complement because it's the opposite or not something. What proportion of the group has green or blue eyes? Okay, switch colors. Probability, I'm going to write this as green or blue. Okay, green or blue, it could be one or the other, so we're going to add those together. So how many people had either green or blue eyes is 2 plus 5 out of 23. Okay, calculator, 2 plus 5 should be 7. Oh, I typed it in. I said 7, so I typed 7. 2 plus 5 is 7. Divided by 23 is 0.3043. Okay, great. So that's what we can do if we have one categorical variable. And I will see you in the next video.